On behalf of Rovini College of Engineering and Technology, myself, Y.JUSTIN Leo, Assistant Professor of Department of Mechanical Engineering, I welcome you all for this Basic Civil and Mechanical Engineering course, and the course code is B8252 for the Regulation 2017. So here in this video session, we'll be studying about the 5th unit of refrigeration and air conditioning. In this, we'll be studying about the terminologies of refrigeration. So this is a 5th unit, and we'll be studying about the terminologies of refrigeration. So this is objective you have. So the students on the main objective for studying the 5th unit of Basic Civil and Mechanical Engineering is to enable them to distinguish the components and working principle of power plant units, internal combustion engines, and refrigeration and air conditioning system. So in Unit 5, refrigeration and air conditioning system, you have the students will be studying about the terminology of refrigeration and air conditioning, principle of vapor compression and absorption system, layout of typical domestic refrigerator, and window and split type room air conditioner. So these are all the textbooks and reference books for the students for this Basic Civil and Mechanical Engineering course, and these are all the course outcomes. So upon completion of this Basic Civil and Mechanical Engineering course, the students will be able to explain the basic concepts of civil and mechanical engineering from the first unit. And from the second unit, the students will be able to select the materials and measurement techniques used in civil engineering. And from the third unit, they will be able to summarize the fundamental building components and civil engineering structures. And the students will be able to illustrate the various internal combustion engines and power plant systems and subsystems with layout after completing the 4th unit. And from the 5th unit, the students will be able to experiment with a typical domestic refrigerator and different types of room conditions. So in this 5th unit, we'll be studying about the terminologies of refrigeration. So this, under this terminologies, we have this refrigerating effect N, which is defined as the quantity of heat extracted from a cold body or space that is to be cooled in a given time. And it is given as N is equal to heat extracted from the cold space by the time taken. And the second one is the specific heat of water and ice. So this is the quantity of heat required to either raise or lower the temperature of 1 kg of water or ice through 1 Kelvin or 1 degree Celsius in 1 second. So the specific heat of water normally is CPW, that is equal to 4.19 kilojoules per kg Kelvin. And the specific heat of ice, that is Cp ice, is equal to 2.1 kilojoules per kg Kelvin. And capacity of refrigeration unit. So capacity of refrigerating machines are normally expressed by the capacity of cooling. So you have the standard unit express. The capacity of refrigerating machine is a ton of refrigeration. So and 1 ton of refrigeration is can be defined as the quantity of heat abstracted to freeze 1 ton of water into 1 ton of ice in a duration of 24 hours at 0 degree Celsius. So you have this heat extracted from at 0 degree Celsius, which is nothing but the latent heat of ice. And you know this latent heat of ice is nothing but it is equal to 336 kilojoules per kg. That is, this 336 kilojoules of heat should be extracted 1 kg of water at 0 degree Celsius in order to convert it into ice. And you have this calculation, that is 1 ton of refrigeration is nothing but 336 into 1000 kilojoules per 24 hours, and that is being converted here per minute, that is 336 into 1000 divided by 24 into 60 kilojoules per minute. So now you have the answer as 1 ton of refrigeration is be equal to 233.333 kilojoules per minute, and that is converted into seconds as 3.8889 kilojoules per second. And next is the coefficient of performance. So what is the coefficient of performance? So coefficient of performance is defined as the ratio of heat extracted at a particular time, that is the refrigerating effect, to the work input. So that is the coefficient of performance. So coefficient of performance is equal to refrigerating effect by work input. That is a coefficient of performance is equal to N. That is a refrigerating effect by W is nothing but the work input. And this COP is always greater than 1. So CFC, free refrigerants. CFC stands for chlorofluorocarbons and is normally used for more than 50 years. And the primary attributes, stability, has been found to be a cause of harm to our environment. So these are primarily cause of the ozone depletion. And this is R22, that is chlorodifluoromethane, CHCF2. So the boiling point is minus 40.8 degrees Celsius, and chlorodifluoromethane R22 is used as pure or in the mixture of refrigeration, that is a medium high temperatures. And this is now also a blowing agent for extruded polystyrene and polyurethane foams, and it is a component in sterilant gas mixtures. And this will be replaced by R134A, that is 1,1,1,2 tetrafluoroethane for meat. So next is R12, that is CCl2F2 dichloro-difluoromethane. And this is because due to its ozone depleting potential is currently replaced by R134A. And the Montreal Protocol, that is the international agreement signed for the protection of this stratospheric ozone layer. So the boiling point is minus 26.6 degrees Celsius. And R134A, H2FCCF3, tetrafluoroethane, and Freon 134A. And it is a blend component for refrigeration. This also can be used as a propellant for aerosol and blowing agent for extruded polystyrene foams. And this replaces CFCR12, dichloro-difluoromethane. And in few years, this HCFCR22 has been used, and its boiling point is 1.013 bar, that is minus 26.6 degrees Celsius. So application of refrigeration. So normally this refrigeration can be used in chemical industries for separating and liquefying the gases, and is used in manufacturing and storing ice. And refrigeration can be used for preservation of perishable food items in cold storage, for cooling water, and can be used for controlling humidity of air manufacture and heat treatment of steels, and for oil chilling, and to remove wax in oil refineries. Refrigeration is highly usable. And in paramedical industries, for preservation of tablets and medicines, refrigeration unit is used. For preserving blood tissues, you can use this refrigeration. And for comfort air conditioning in hospitals, theaters, this refrigeration unit is used. And coming to the properties of refrigeration, normally a good refrigerant should have a high latent heat of vaporization, should have low boiling and low freezing point, should be non-toxic and non-corrosive, and it should be non-flammable, non-explosive, should have high thermal conductivity and easy to handle, should have low specific volume of vapor, but the coefficient of performance should be high. So with this, we come to an end with this unit. So thank you and have a great day.